Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is solid-state chemistry, crystalline solids and defects. This is a fundamental chapter that builds the foundation for understanding the structure of solids, which plays a significant role in explaining the behavior of materials used in various industries. So, let's get started. To begin with, solid-state chemistry focuses on the study of solids, which have a definite shape and volume due to the strong forces of attraction between their constituent particles. Solids can be broadly classified into two categories: crystalline solids and amorphous solids. However, today, our primary focus will be on crystalline solids and the types of defects that occur in them. Crystalline solids are characterized by a highly ordered arrangement of particles. The constituent particles, whether atoms, ions, or molecules, are arranged in a repeating pattern over a long range, giving rise to a well-defined geometry. This orderly arrangement is known as a crystal lattice. Crystalline solids exhibit a sharp melting point and distinct physical properties along different directions, a phenomenon known as anisotropy. Depending on the nature of the constituent particles and the type of bonding between them, crystalline solids can be classified into four main types: ionic, covalent, metallic, and molecular solids. Ionic solids are formed by the electrostatic force of attraction between oppositely charged ions, such as in sodium chloride. Covalent solids, also known as network solids, have atoms held together by covalent bonds, making them extremely hard and having high melting points, such as diamond. Metallic solids consist of a lattice of metal cations surrounded by a sea of delocalized electrons, which gives them high electrical and thermal conductivity. Molecular solids, on the other hand, are held together by weak van der Waals forces, resulting in low melting and boiling points, such as in iodine. Now, let's talk about crystal defects, which occur when there is a deviation from the perfect arrangement of particles in a crystal lattice. These defects can significantly affect the physical and chemical properties of solids. Broadly, defects can be classified into point defects and line defects. Point defects are irregularities that occur at individual lattice points and can be further categorized into three types. The first type is vacancy defect, where some lattice points are unoccupied because atoms or ions are missing from their positions. This leads to a decrease in the density of the solid. The second type is interstitial defect, where extra atoms or ions occupy interstitial sites, which are the small voids between the lattice points. This type of defect increases the density of the solid. The third type is the Schottky defect, which occurs in ionic solids where an equal number of cations and anions are missing from their lattice positions. This type of defect is observed in solids where the size of cations and anions is almost equal, such as sodium chloride. Schottky defects reduce the density of the crystal but maintain electrical neutrality. On the other hand, Frenkel defect occurs when an ion leaves its regular lattice site and occupies an interstitial site, creating a vacancy in its original position. This type of defect is observed in ionic solids where there is a significant difference in the size of cations and anions, such as in silver chloride. Frenkel defects do not affect the overall density of the solid. In addition to these, there are impurity defects, which occur when foreign atoms or ions replace some of the host atoms or occupy interstitial sites in the crystal. These defects can be intentional, as in the case of doping in semiconductors, where impurities like boron or phosphorus are added to silicon to modify its electrical properties. Moving on to line defects, these occur when there is an irregularity along a line of atoms in the crystal lattice. One of the most common line defects is dislocation, which can be either an edge dislocation or a screw dislocation. These defects play a crucial role in determining the mechanical properties of materials, such as their strength and ductility. Defects in crystalline solids are not always undesirable. In fact, they can sometimes enhance the properties of materials. For example, adding a small amount of carbon to iron creates steel, which is much stronger than pure iron. Similarly, doping semiconductors with specific impurities enhances their conductivity, making them suitable for use in electronic devices. One common type of defect is a point defect, which occurs at the atomic level. These can be classified into three main categories: vacancy defects, interstitial defects, and substitutional defects. A vacancy defect arises when an atom is missing from its expected lattice position, creating a void. This type of defect can affect the density and conductivity of the solid. An interstitial defect occurs when an extra atom is inserted into the lattice at a position where it does not normally belong. This can cause distortions in the structure, altering its mechanical properties. In a substitutional defect, one atom in the lattice is replaced by a different type of atom, which can modify the electrical and optical behavior of the material. Crystalline solids and their defects are essential concepts that not only help us understand the behavior of materials but also have practical applications in industries such as metallurgy, electronics, and nanotechnology. To summarize, crystalline solids exhibit a well-ordered arrangement of particles, which gives them unique properties. However, the presence of defects can alter these properties in significant ways. Understanding these concepts will help you solve numerical problems and gain a deeper insight into the fascinating world of solid-state chemistry. That's it for today's session on solid-state chemistry. I hope this detailed explanation has clarified your doubts and helped you develop a strong understanding of crystalline solids and defects. Don't forget to like, share, and subscribe to AskPrep for more informative videos on chemistry. Thank you. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.